Here we are asked to graph the function 1 over x squared. And this is one of our basic, our toolkit functions. We want to be aware of how to sketch this correctly. The first thing we want to notice is that x cannot equal 0. Because that would give us a 0 in the denominator, and division by 0 is undefined. Now from there, I'm going to set up a little bit, set up a table. I'm going to choose some x values and find the corresponding outputs, 1 over x squared. So let's suppose I chose x equals 1. If x was equal to 1, then 1 over 1 squared, 1 over 1, is 1. And so that gives me the point 1, 1. Similarly, if x was negative 1, then I'd have 1 over negative 1 squared. Negative 1 squared is, again, positive 1, and 1 divided by 1 is 1. So I have the point negative 1, 1. Now what if x was 2? If x was 2, then I'd have 1 over 2 squared, 1 over 4, or 0.25. And so then that would give me the point 2.25. And similarly, if x was negative 2 squared is again 4. So again, this would give me 1/4. And so I'd have the point negative 2.25. And so we've got a few points here. I'm going to plot them in a different color. Let's see, I've got 1, 1 as a point. I have 2 and 0.25, so that's about there. And I have negative 1, 1. And I have negative 2 and 0.25. And so what if we chose a number between, say, 0 and 1? So how about what if we chose 1/2 as my input? If my input was 1/2, then my output would be 1 over 1/2 squared. That's 1 over 1/4. And 1 divided by 1/4 is 4. And so I have the point 1/2, or 0.5 if you want a decimal, comma 4. 1/2, comma 4. 0.5, comma 4. And similarly, if x was negative 1/2, the output would again be 4. And so I have the point negative 1/2, 4. And again, I'll plot that in blue. What if I chose a larger number? Say, what if I let x equal, say, 10? If my input was 10, well, 10 squared is 100. I'd have 1 over 100 as my output. And so I have the point 10, comma 0.01. 1 over 100 is 1/100th. And that point, oh, look, it's over here, 10 and 0.01. That's really close to the x-axis. And again, if I chose the x value negative 10, the output would again be 1 over 100. And that would give me the point negative 10, comma 0.01. So that might be over here. And now remember, x cannot equal 0. And what I see from my graph in blue, I see this large value, fairly large value, and I wonder what happens if I get closer and closer to 0. So let's continue. What if I said, hey, what if I let x equal, how about 0.25? What if I let x equal 1/4? If I let x equal 1/4, then 1 over x squared, so that would be 1 over 1/16, which is 16. So if my input, if x is 1/4, my output is way up here. It's like 16 is maybe up here somewhere. And the same thing will happen, or something similar will happen, if my input was negative 1/4. My output would again be 16. And what I see here is that there's what we call asymptotic behaviors. There's an asymptote to the graph at x equals 0. And we represent that asymptote, in this case, a vertical asymptote, at x equals 0. And we represent that with a dotted line. And also, notice we had our y values were getting very close to 0, but they can't ever actually equal 0. And again, I'll show that with, again, a dotted line. And here I have a horizontal asymptote. At y equals 0. And so these asymptotes, we draw them with dotted lines because they're not really the curve, they're not really the graph of the function, but they're guidelines to help us sketch the function. And the actual sketch of the function looks like this. It increases and is asymptotic near x equals 0. This is tough to draw on my tablet. All right, and it does something similar on the other side. And let's put some arrows there saying it continues like that, and it does something similar on this side. So it is asymptotic to both the x-axis and the y-axis. It'll never actually cross either of those axes. There is no x-intercept nor y-intercept to this function. It's asymptotic to both axes. And so there's a graph of the function 1 over x squared.